Welcome to Coach Taylor's Class Notes, and today we're going to be looking at 3.6 notes and start our transformations notes, specifically looking at translations. So a transformation is an operation that maps the original figure, called the pre-image, onto a new figure called the image. On the graph to the left, triangle ABC is the pre-image, and triangle A prime, B prime, C prime is the image. So again, we read that little apostrophe as prime. So again, ABC right here, this triangle is our pre-image, and then ABC prime is our image. So a transformation can change the location, which is what happened on the image above. It can change the size of the image, or it can change the orientation of the image. So we have two different types of transformations, and we categorize them into rigid motions and non-rigid motions. So primarily we're going to look at rigid motions. So a rigid motion is a motion that maintains the same size and shape. So the first three different transformations that we're going to look at are rigid motions, and those are our translations, which we're going to talk about today. It is our reflections, and it is our rotations. So the size will always be the exact same. It will have the same shape no matter what, but it's going to be in a different location, or it's going to be oriented differently on the coordinate plane. So today our main focus is going to be on translations. So a translation means to slide a figure up or down, and or left or right. And left or right is also side to side. So the way that we note this, or the way that we write a rule for coordinate notation, is we always write x comma y because that is our pre-image point. And then we draw an arrow to show that a transformation of some sort is happening. And so with translations, the transformation that's happening is it's going to be x plus h. Let me make that actually look like an h, comma, y plus k. I'm having a bad writing day, guys, sorry. Y plus k. And so in this problem, our h represents the horizontal shift. Which is the x-axis. A left shift is a negative. A right shift is a positive. And our k represents the vertical shift, which is the y-axis. A shift up is positive. A shift down is negative. All right, so let's look at this a couple of different ways. So anytime we're given a graph and it asks us to write the rule, what we're looking for is x comma y arrow x plus h comma y plus k. So for the first thing that we need to do is we need to identify the pre-image and the image. So if we look right here, we have our W, and here I know it's hard to see, but we have our W prime. So we are going to see what our transformation is from W to W prime. So I go 1, 2, 3, 4 left, and then I go 1, 2, 3 down. Now, real quick, I'm just going to make sure that all the rest of ours follow that same rule. 1, 2, 3, 4, 1, 2, 3. Yep. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. So once I have 4 left and I have 3 down, that is what is happening in this translation. So we said on the previous page that 4 left is a negative 4 and left is our x value. And we said that 3 down is negative 3 and 3 or down, up and down is our y value. So if I were to write a rule for this, it would be x comma y, draw an arrow to show my transformation. It's going to be x minus 4 comma y minus 3. And so that's how, if we're given a graph, we can write our rule of our translation. So now let's look at when they give us the rule, how we can graph this and how we can figure out the endpoints. So if they give us coordinates, we're always going to plot those coordinates. So Q is negative 6, negative 1. R is negative 3, 1. S is 1, negative 5. And then T is negative 2, negative 7. So this is Q, R, S, T. And this is my pre-image, or the image that I'm given. And so now let's look at our rule that we need to apply. So it's x plus 5, and so it's positive. I know we're going to go to the right 5. And then if it's plus 7 for y, we're going to go up 7 because positive means up. So when it's time to do our translations, we need to go right 5, 1, 2, 3, 4, 5, up 7, 1, 2, 3, 4, 5. So this point right here is going to be Q prime. Now, you can do it using a graph, or if you know our basic math coordinates, if I'm going to take x plus 5, I know that negative 6, because Q's original x point is negative 6. Negative 6 plus 5 is going to get me a negative 1. And I know a negative 1 plus 7 is going to get me a 6. So I can also do that math there. And then let's just check to make sure that's where Q prime ended up on the graph. Negative 1, 2, and then 1, 2, 3, 4, 5. Yep. And 6, that's where it goes. So now we're going to do the same thing with R. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So again, I'm going to go negative 3 plus 5 should get me a positive 2. 1 plus 7 should get me 8. And that is where our prime should be. And yes, if we count everything out, that is in fact where it is. So now we need to look at S. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And so that's where S prime should be. And then if we take S, 1 plus 5 is 6. Oh, I wrote R in the wrong spot. Sorry, guys. 2 comma 8 is R. And let me erase that. And my S coordinate is, so I said 1 plus 5 is 6. And then negative 5 plus 7 should be a positive 2, which is in fact where S is located. And we have our last one, which is T. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So this should be T prime. And if T is a negative 2 plus 5 should get me a positive 3. Negative 7 plus 7 should get me 0, which yes, in fact, is where it is. And then if we play connect the dots, QRST prime should be the same size. It should be the same shape. Everything should be the same distance. They should be congruent figures. All right, so now let's look at our next one. So if we're looking at the rule here, our rule is x negative 7 comma y. I know that we're going to go left 7. And then because y does not have a plus or minus to it, there's going to be no y change. So my y coordinates are going to be the same no matter what. Let me just make one slight adjustment real quick. So let me graph my original or my image, pre-image. That's W. That's X. That's Y. And then that's Z. W, X, Y, Z. And so what I know is that we're going to go 7 left. So 1, 2, 3, 4, 5, 6, 7. So this is W prime. And W prime, if it was at 1 and we're subtracting 7, it should be at -6. We said the Y value is not going to change, so I can just write it down. 1, 2, 3, 4, 5, 6, 7. So that should be X prime. And 6 minus 7 should be a -1. The Y value didn't change, so we just write down the Y coordinate. Y, 1, 2, 3, 4, 5, 6, 7. This is Y prime, which 4 minus 7 is a -3, and the Y value did not change. 1, 2, 3, 4, 5, 6, 7. This is my Z prime. And so if we go -1 minus 7, we should get a -8, and then our Y value does not change. Sorry, went and connected the wrong dots. So if we look at this, our shape should be the exact same size. They should be the same shape. Nothing changed but its locations on the XY coordinate. And so that is translations and our introduction to all transformations.